Hey everybody, welcome to Pre-algebra. We're in Chapter 2, and Chapter 2 is going to be all about solving equations. Alright, so there are probably some good things to know before we start getting to Chapter 2, so here's what I want you to do. I want you to pause the video, and in your notes I want you to write these two questions out, and then I want you to give the answer. So take a minute, pause the video, write these out, think about the answers, write them down in your notebook, play the video, and see if you got it correct. Alright, so hopefully up here you saw, let's see, write a variable expression given the phrase 6 more than a number. So what does that mean? Well, a variable expression means I'm going to have a variable and it's going to be an expression. So no equal sign. So there's going to be some variable there. And that variable is going to stand for a number, okay? But what about a number? Well, I have 6 more than a number. So I've got this number and I'm adding to it, it's a plus sign, 6. There you go, 6 more than a number. Down here, the quotient of a number and 5. Well, we know that quotient means division, okay, or we can write it as a fraction bar. And what are we dividing? Well, let's see, the quotient of a number and 5. Well, a number comes first, so we're going to put that first. And what does a number mean? Well, we don't know. So that means it's a variable. We'll just use x. And then a number and 5. So the 5 goes on the other side. Again, you could write it like this, the quotient of a number and 5. Alright, today we're starting Chapter 2 with Section 2.1, Properties and Operations. So the first thing we're going to learn about is the commutative property of addition. Alright, so what does that mean? Well, commutative, we'll explain that, but first we'll just kind of state the obvious, addition, okay? We're going to use this property when we are adding things, okay? And let's go back to the word commutative. What does that mean? Well, if you ever think about a commuter train, okay, commuter train, you hop on at your, well, you probably don't hop on right outside your house unless you live by the train station. But anyway, you get on the train, that's a terrible looking train, and you go from your house to work, right, in your skyscraper, okay? So you commute, you move places. So commuting means moving, so we're going to be moving things in an addition problem, okay? So that would look like taking something as simple as 4 plus 7, meaning I can rearrange that to be 7 plus 4. And that might seem silly, but, yeah, I mean, we can do that. You probably have learned that or you've known that for a long time. But there's a property behind it that says we can do that, and that's the commutative property of addition. Now, we could also take something like 4 plus negative 7, okay, and we could rearrange that also. Now it has a negative sign, but does that matter? Well, no, because we are adding. The operation in this expression here is adding 4 plus negative 7, so I could rearrange that to be negative 7 plus a 4. Still use the commutative property of addition. Of course, these are both 11, and this would be negative 3, and that would be negative 3. Now, we can also use that in places like this. Nine plus x plus 7. Well, what would we do there? Well, the commutative property of addition says I can move things around. So I'm actually going to have this 7 take x's spot and x take 7's spot. So it's now going to be 9 plus 7 plus x. Okay? And now what I can do is I can add these two. 9 and 7. Well, 9 plus 7 is 16 plus x. And that's as far as I can go because 16 and x are not like terms, so I can't combine them. So it just stays put. Alright, so next we have the commutative property of multiplication. You can probably guess that it's going to be pretty similar. Something like 3 times 9 can be rearranged to be 9 times 3. Okay, what about 3 times negative 9 though? How could I rearrange that? Could have negative 9 times 3. You might also see that written 3 parentheses negative 9. And what you could do is, again, switch and have negative 9 outside the parentheses and then the 3 on the inside. Either way, they all equal negative 27, and these are positive 27. So let's talk about the associative property of addition. Okay, well, what does that state? Well, what it actually states is kind of something we hinted at before. Association, okay, means that something is kind of in relationship with something else. Okay, so we're going to talk about addition problems where you got numbers or variables that are associating with each other. And certain ones are going to associate, and then there might be ones that are not associating. What does all that mean? Well, if you had 9 plus 3 plus 2, the associative property of addition says, you know what, I can change this into 9 plus 3 plus 2 with the parentheses right there, meaning I'm going to add 9 and 3 first, which would get me 12 plus 2, and that, of course, then gets you 14. Or you could do this. Put the parentheses around the 3 and the 2, which would then leave you with 9 plus, parentheses, order of operations, got to do that first. 3 plus 2 is 5, and then you get 9 plus 5, which also equals 14. So if you notice, get the same answer either way. Why? Because of the associative property of addition says that you can do it either way. Alright, so let's talk about the associative property of multiplication. Okay, again, associations, we're talking about parentheses and certain things associating with other things. So if I had 3 times 2 times 7, okay, that's one way of writing that, but I could also write it 3 times, parentheses, 2 times 7. Of course, now we obey order of operations in both of these, and I can do this one first. 3 times 2, 6 times 7 gets you 42. 2 times 7, well, it's like saying 3 times 14, so 14, 28, 42. So either way you do it, you get the same answer because of the associative property of multiplication. Alright, so what we're going to do here is we're going to evaluate 6xy when x is 2 and y is negative 4. Okay, and then what we're going to do is, as we're doing that, we're going to discuss kind of what properties that we're actually using. So 6xy really means 6 times x times y, so that probably tells me whatever property or properties I'm going to use are going to be of multiplication. Okay, so what that means is I take a 2 and I plug it in for x. I'm going to take a y, or I'm going to take a negative 4 and plug it in for y, so now I get 6 times 2 times negative 4, put my negatives in parentheses. And so now, well, I can do a couple things. I could associate these two, say, well, let's do 6 times 2, which is 12, times negative 4. But I also could have associated these two and had 6 times, well, 2 times negative 4 would be negative 8. Okay, either way, down here, now you get negative 48, and here you get negative 48, both ways. So what was happening there is you were using the associative property of multiplication. Okay, maybe an even better one would be this one. We're going to evaluate this. So what I want you to do is pause the video. I want you to evaluate this, given these things here, and justify your steps by saying what property you're using as you're doing this. So go ahead, pause the video, try that, play it when you're done. Alright, so hopefully you got 4 times A times B, and then you plugged in negative 7 for A and 25 for B, and got 4 times negative 7 times 25. Okay, so now I could just, associate these two and associate these, or associate these two. However, if I'm using mental math, I want to be quick about this, what I can realize is that, you know what, I know what 4 times 25 is. And the commutative property of multiplication, okay, so I'll say commutative property of multiplication, CM, says that I can rearrange this into 4 times 25 times negative 7. And that helps me because now I can associate these two, which is 4 times 25, 100. And then tack on the times negative 7, and then I know 100 times negative 7 is going to get me negative 700. So here you use the commutative property of multiplication to go from here to here. And then in the red, associating the 4 and the 25 was the associative property of multiplication. Okay, so we're going to quickly go through the identity properties. So first we have the identity property of multiplication. Okay, so what does identity mean? Well, I mean, when we're using it in properties, so that word, what we want to think of is I want to preserve the identity. Right? So if you want to preserve your identity, you're not going to change anything about yourself. It's the same thing here. The identity property of multiplication says that if I have negative 4,292 and I multiply that by 1, well, we all know that stays negative 4,292. You didn't change this value because you only multiplied it by 1. Similarly, 5 times 1, well, that equals 5. You had a 5, you multiplied it by 1, and it stayed the same. It maintained its identity, okay? So the product of a number and the multiplicative identity is that number, just meaning 5 times 1 is 5, okay? Okay, so what about the identity property of addition? Okay, well, again, identity, keeping things the same, not changing it. So if you had negative 8 and you had to add something to it to keep it the same, what would that be? Well, of course, you would say add 0, because negative 8 plus 0 is still just negative 8. Okay, so the sum of a number, okay, and the additive identity, which is 0, 0 is called the additive identity. It's going to be that number, which in this case was negative 8. All right, so there you go, guys. That's 2.1. I'll see you in class.